So, okay, we are going to cover lessons 78, 79, 80, and 81. I know that seems like a lot, but we are at the end of the third quarter and we still have a lot to go. So you're going to have to buckle down and try to hang in there. All right, so the first thing we're going to look at is lesson 78, which is about the hyperbola. It's another conic section. Remember, the ellipse is the conic section you get when you cut through a cone with a plane that is tilted. So you get this oval shape. Remember that an ellipse is the locus of all points such that the sum of the distances from the foci to any point on the ellipse is a constant. So you have these 2 points called the foci, and any point on the ellipse, if you add the distances from that point to the foci, you get a constant all the time. It's the same number no matter where you draw your lines from on that ellipse. You'll get the same value for the sum of those distances. And remember, the standard form of the equation of an ellipse is x squared over a squared plus y squared over b squared equals 1. And we're only looking at ellipses that are centered at the origin. So the hyperbola is a double curve, and it is called a conic section because if you cut through a cone with a plane and it cuts through both cones, you get this hyperbola shape. The hyperbola has 2 foci, again, 2 points called the foci, and this time the difference of the distances from any point on the hyperbola to the foci is a constant. So when you have a hyperbola that has points on the x-axis and is centered at the origin, you're going to have the equation x squared over a squared minus y squared over b squared equals 1, where a is the x-coordinate of the 2 points that cross the x-axis that are on the hyperbola. One of them will be negative a and the other will be positive a. And then if you have a hyperbola that is vertical, like this one on the right, where the points on the hyperbola are on the y-axis, the y term comes first in the equation. You have y squared over a squared minus x squared over b squared equals 1. And then the points on the hyperbola that are on the y-axis are 0a and 0 negative a. So for the hyperbola where it is on the x-axis, the x term comes first, the x squared term comes first. And for the hyperbola that has points on the y-axis, the y squared term comes first. So if we wanted to sketch this hyperbola, the first thing we're going to do is set y equal to 0. So we will get x squared over 9 minus 0 over 4 equals 1. So x squared over 9 equals 1. So x squared equals 9, which means that x is plus or minus 3. So those 2 points, plus 3, where x is plus 3, and y is 0, and minus 3, where y is 0, those are going to be on the hyperbola, so on the x-axis. Then we can set x equal to 0 in the equation, and that will give us 0 over 9 minus y squared over 4 equals 1. And that means that negative y squared over 4 is equal to 1. So y squared is equal to negative 4, which means that y is plus or minus 2i. Now, obviously, that is not in the xy plane. That is not a number that exists in the real numbers. So we're just going to put little x marks on those 2 places, the plus 2 on the y-axis and the minus 2 on the y-axis. And the reason we're going to do that is because we want to draw the asymptotes. The asymptotes are 2 lines that this graph will approach but never actually touch. So we're going to make a rectangle that goes through the 2 points on the x-axis and the 2 points that are not really on the hyperbola but are the 2's that we put x's on the y-axis because of that 2i. And now we're going to draw the diagonals of that rectangle. And we're going to write the equations of those 2 lines. So that rectangle where the line has a positive slope, that from point to point, it goes through the origins and it goes through 3, 2. So that is y equals 2/3 x up to and over 3. The other is y equals negative 2/3 x. Same line, but it has a negative slope. So those are the asymptotes. These are the lines that the graph will approach but never reach. So the hyperbola, when you draw it, it should approach the asymptotes. It goes through the points that are on the x-axis, and then it approaches the asymptotes like that. Now we have one where the y squared term is going to come first. So this one is going to go, it's going to go through the y-axis. So if we set x equal to 0 this time, we will have y squared over 4 minus 0 over 25 equals 1. So y squared over 4 is going to be 1. So y squared is going to be 4, which means y is plus or minus 2. So I'm putting those 2 points on the graph. They are actually on the hyperbola. If you let y equal 0, again, what's going to happen this time is that you are going to get a complex number for x. So negative x squared over 25 is 1. So x squared is negative 25, which means that x is plus or minus 5i. So the plus and minus 5i are not on the hyperbola because they're not in the xy plane. Those are imaginary numbers. But we will go ahead and put little x marks on plus 5 and minus 5 so we can draw our rectangle. So we're going to draw this rectangle, and then we're going to draw the diagonals. Those are the asymptotes. So that diagonal, it goes through the origin, and then from point to point, it goes up to and over 5 to that point. 5, 2. So it is y equals 2/5 x. And then the other asymptote, which is the other diagonal, will have y equals negative 2/5 x for the equation of that asymptote. Now we can draw the hyperbola through the points that are actually on the hyperbola on the y-axis, plus 2 and minus 2, and we want it to approach the 2 asymptotes. Given the hyperbola 4y squared minus 9x squared minus 36 equals 0, we want to write the equations in standard form, find the vertices, and the equations of the asymptotes. So we're going to first of all put it in the right form. So we will have to divide everything through by 36. And now we will set x equal to 0 and see what we get for y. We already know it's going to be 3 and plus 3 and minus 3, but we'll just do it anyway, just so we make sure we understand. So y is plus or minus 3. We're going to put those 2 points on the y-axis. Now, if we were to set y equal to 0, again, we're going to get an imaginary number for x. Those points are not on this graph, but we will put a little x on plus or minus 2 on the x-axis just so we can draw our rectangle, which looks like this, and then we will draw our asymptotes. And just remember to write the equation of the asymptote. It's a line that has its y-intercept and x-intercept at 0, and it has a slope of up 3 and back 2, so that's negative 3/2. So y equals negative 3/2 x, and then the other asymptote has a positive slope, so that's y equals 3/2 x. And now we can draw the hyperbola, which goes through the points on the y-axis, and it should approach the asymptotes.